Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about disasters and preparing for disasters and
Disaster.
recovering from disasters. So, Nate, how's it going?
Not bad. Not bad. Disasters. We've all got stories. I'm sure some of them will bubble up as we're in the deeper dive. But to start with, we've got a tar demo, right? So
Yeah.
I can bring up mine. Just a sec here. This is the problem with double duty. Okay, so I'm sorry about the font size. Web console is hard. Wait, is there like a no? There's not a plus in the virtual consoles. I'm going to talk to Brian Smith and tell him this needs to be a feature. All right, so imagine the scenario, right? I've got a machine here that is supposed to be a web server, and I don't know. I'm playing the part of a junior admin today, and I accidentally deleted the web root, right? So senior admin says that's okay. There's a backup, and hold on, gotta select the right window here. And sure enough, I've got this web backup right here. Okay, so we're gonna extract the web backup. Okay, we're gonna say extract. We're gonna do it verbose so we can tell what's going on. It's a gzip file, so we need to add a z, and we're gonna preserve the original file locations, and we're gonna tell it what file we're gonna use, and that's this web backup right here, right? So we're gonna go ahead and extract that, and you can see, oh boy, Scott, there's a lot of stuff in there that I didn't expect.
Oh yeah.
Oh man, that doesn't look good.
Just out of
All right.
curiosity, Nate, where did you get this tar archive?
Well, someone gave it to me. They said this is the backup, so I restored the backup.
But like, was it on the same operating system that you're running?
Well, no, I think it came from our last web server.
So it's like, I don't know.
We recently went through a migration, right? And I was tasked with trying to get the web server up and running.
So I see what you have left on the screen there. For example,
yeah, that doesn't look good.
You added back VM Linux 310, right?
Yeah, that doesn't sound happy. You know what? Let's just let's try to start up the web server just to see what happens. Oh, error while loading shared libraries, libgcrypt. That doesn't sound good, does it? All right.
Yeah.
Well, you know what? Let's here. Let me clear the screen so we can see what's going on. And then I gotta scroll up. I'm telling you, this web console thing. Let's just reboot. How about that? Oh man. All right. I think maybe I've broken this machine.
Yeah. Yeah.
You know what? Let's, for good measure, why don't we just reboot it?
I think at this point you're going to be very unhappy with that reboot.
Oh yeah, that's not good. All right, Scott, I hope you have a demo prepared because I think I just cooked my lab machine.
As luck would have it, I do have a lab prepared. So
see that? Always be prepared, right?
That's right. It's disasters, right? What happens when you just disastrously destroyed your machine? You got to have a backup plan. All right, so Nate, I think one of the problems that you encountered was that when that tar archive was created, it preserved the path names of the files. So when you unbundled it in your on your machine, it actually overwrote files all over your box. And so we talked before the show, and you made a tar archive of that as a RHEL 7 box.
Yes.
And you just like overwrote all of these files on your RHEL 9 box with RHEL 7 stuff. And so, like, for example, that old libcrypt library should have been a RHEL 9 libcrypt library, but now it's a RHEL 7 libcrypt library, which is like badness.
Yes, not good. Not good. Now, obviously, like normally a web root backup wouldn't include boot and wouldn't include whatever. So it's a little contrived, but you know what? It can happen, right? If you're doing a full system backup and you carelessly restore, the entire backup, that can be a problem. So don't preserve original paths. It's a bad move.
And I noticed you did a couple other things too. Like, there's rules of backup safety, right? Like, look at the backup before you restore it to make sure that you know what's in there. And so let's do a little bit of like entry level tar stuff. And then we could talk more about like strategy. I know that Nate, you have a demo today on like automating your backups, and then we're going to talk about other backup tools. But why don't we start with tar, because that's like the universal backup tool across all Unixes and Linuxes. Before I start, I will say, as we're talking about backups, if your company or organization has a backup utility that has a Linux client, and that's their standard tool that they use for their stuff, you should use that, right?
Yeah.
So a whole lot of partners that Red Hat works with to help support things on for additional software like NetBack and Tivoli Storage Manager, and like lots. But that means that you can plug into the existing policies, procedures, types of backups, disaster recovery plans that the other people in your organization use that also use this client, right? So that you can have similar strategies as the Windows machine team or somebody else in the organization, right? So tar is the ubiquitous. It exists on all Unixes and Linuxes, and we'll start with that. But if there's another tool that is already in use where you work, that should be your primary target. All right. Yeah. So, Nate, you wanted to make a backup of your web root, right? So
yeah, that was the goal. That was the goal.
Yeah, create a backup or a tar archive verbosely. Tell me what you're putting into it. And tar is tape archive. So instead of using a tape, I want you to put all this backup stuff into a file. And I'm going to call that file.
That's a weird idea.
I know. Big backup tar.
Are people still using tapes? I'm curious.
There are people that still use tapes. And we'll just do Etsy HTTPD. All right, so we're just going to grab the Etsy stuff out of HTTPD. And there we go. That's all the stuff that was pulled in. Now, you'll notice when I ran it, you may not have seen this little tiny thing right here. This is the problem that Nate had earlier. So while it pulled all of these files in, if I do a tar tf, the table of contents from the file config backup.tar, right? Notice that leading slash is not there.
Yep. Okay. Yep. And I did actually try some things with the quote unquote bad archive. If you tried to extract it in a directory other than root and did not include the P flag when you extracted it, it still didn't destroy everything. You had to include P, the preserve flag.
I challenge that assertion. And
well, it didn't break my system, and it extracted inside of the directory that I was in. I would still be careful, right? But it's not as easy to do as I may have led into in my demo.
So I think it is determined by that capital P flag, and we'll talk about that in a second.
Right.
All right. So I just took my config backup tar and put it in temp. Right there, it is right there. And when I extract from it, tar xpf, extract, tell me what you're pulling out, and I'm going to give you a file name. It unbundles it locally, and so now I have this Etsy subdirectory in my temp directory.
Mm-hmm.
And in there is that HTTP directory that I copied, and then there's all the actual stuff for my backup. So whenever you use a tar archive, I always like to take a quick look with tar tf, so it'll show me what's in there, and then you can extract it. And here we go. Nate, did you know that you could also extract individual files?
I was aware of that. I don't really do it that often, though.
So if you do a tar extract verbosely file config backup.tar, and then you tell it, I want Etsy http conf httpd.conf. Oh, hold on. I put on the slash. It just pulls out this one file. Now it'll actually create the entire directory structure. So let me do it one more time. So, man,
typo.
I'm not doing good with typing today. Etsy, right? There's one directory underneath. There's one directory underneath that. And there's one file in there. right? Because when I extracted it, I said, pull out this one file. And so it recreates the directory structure down to that one file and pulls it out. So that's a way that once you do a table of contents listing, if you don't want everything, you just want that one thing, you can just pull that one thing or that one directory out that has several files in it, instead of restoring the whole thing. And that might be really useful if you're dealing with really large backups, because you don't want to dedicate all the local file system space for storing the entire archive to be restored. All right, so -P. Let's talk for a moment about -P. All right. So when you create a tar archive, and I'll just recall my previous command from history. If you include the P option, notice this time it didn't give me that nice error message that it's removing the / from my archive, which means if I do a tar tf on that archive, it stored the files with their fully qualified path name.
Yep.
So before, without that bleeding /, it created a Etsy directory, my current working directory, and then everything was undone underneath that locally created Etsy directory. But now in my archive, I actually say that all of these files are /something. We're giving the absolute path name, which means when I untar it, it's going to spray them around in the directory structure, overwriting all the files that are in place before. So that's where -P is kind of a rough go.
Yes, it can be. It sounds like an attractive option because you're like, well, of course I want to put the files back where they came from. However, right? Warning bells. Make sure that you're not overwriting files that, check that table of contents first and make sure there's not files in there that you're going to regret overwriting if you're going to use the preserve flag.
Yeah. And this is also like a big no-no. Like there's a reason why the capital P option is not the default and it requires an extra option, because tar is used for all kinds of things, like moving data from one system to another, irregardless of what type of system it is. Like if I wanted to share with Nate my Apache content and he's running another distribution like Ubuntu, I might still tar it all up and send it to him. But if he then takes this, this archive and unpacks it on his Ubuntu box, like that's not where Ubuntu even puts web content, right?
Right.
So it can cause a lot of problems if you're not careful with it.
But there are some valid use cases for it. For example, when you package up a container or certain types of cloud images and whatnot, they're tar files at their base, right? And that's actually how they get deployed. They go to an empty disk and they untar the thing and it writes out the entire file system as you'd expect it, right? So that's why that option even exists if it's so dangerous.
So the other thing I want to talk about quickly with our tar overview is compression. So when I was creating my tar archive right here, whoops, right there, and I'll go ahead and take out the -P option. You can also, when you're creating it, not only create the tar archive, but then go ahead and compress it as well. And there are two options that handle compression. One is the Z option that uses gzip compression, which is the Lempel Zev. Whoops, hold on. Let me do that one more time. See, I want to make the other one, and I need to also change its extension so that people know that it's compressed. Man, there we go. Boom.
Why should you type the command if it's somewhere in your history, even if it's 100 commands back, right?
I wasn't expecting it to be that far back. All right. All right, so I have two, right? This was my one that I made originally that was uncompressed. And then here's the one that I made that's compressed. And you can see that it did a pretty good job of compressing it, right? It went from 71K of file storage to 16K, almost 17K of file storage. gzip compression uses a combination of Lempel Zev compression algorithm as well as Huffman coding to try and deduplicate data and other stuff to get you down to this smaller size. If I run file, it tells me that this is gzip data, right? It actually doesn't know what's inside the gzip because I'd have to ungzip it to be able to tell it that. So that's why we use the extension tgz, or sometimes you'll see .tar.gz, so that people know that it's not only GNU zipped, but it's also a tar archive inside of it. And with extraction, Nate, I noticed you used the Z option for extracting.
Mm-hmm.
Turns out you don't have to do that.
Yes, tar is smarter now than it used to be, but it's muscle memory for me at this point. I always use Z, and then it's like, but this file is a bzip or an xz, so and then it doesn't work, and I have to remember what the other flag is. However, if I would just leave the flag off, it figures it out and does the extraction.
Correct. So it sees the tar will actually now natively go, oh, this is gzip compression. Cool. Let me ungzip it, and then I'll untar it. And then the other one that Nate mentioned is bzip2 compression. So if I make my bz2, right, and again, I'm changing the extension so that people know how it was created. While tar for us is smart enough to know that you don't have to use the extra option, that may not be true of all Unixes. So right. There we go. So this tbz2 is slightly smaller. It uses the Burroughs-Williams compression algorithm for doing compression. Both of them do really well on text archives, right? So all my config files, that was just text. They do really good on that. Right. The BZ2 algorithm, which is Burroughs-Wheeler, does pretty good at mixed content. So if you have a mix of binary and text, it'll actually make it smaller. And neither one of them do well with just binary content. So you shouldn't even bother if you're making a tar archive with just binary content.
You could, but yeah, you're right. It's just why? Just add some more overhead. Well, but you can still tar binary content together, so it's in one file, so it's easy to move around. But yeah.
Right. But if you actually compress it, sometimes the compressed version is actually bigger.
I've seen that. Depends on the data.
So
depends on the binary data.
So Nate, that's a little bit on tar. I know that after the transition, we're going to talk more about disaster recovery planning. And then we have some more demos, right?
Yeah. More demos. Always good. Hang on, I have to find the transition button.
Well, don't forget to mash that like and subscribe so that we can keep making content like this. Our bosses like to know that we're doing a good job, right? And that's one of the ways that we tell them we're doing a good job.
Yeah, if you want to give Nate and Scott a pat on the back, like the show, subscribe, do those things.
And then, so after the transition, we're going to talk more just conceptually about plans for managing disaster planning. We're also going to do a demo, I think, Nate, of automating tar.
I didn't cook up a demo for that. We can talk about it, but yeah, well, I do some stuff. We'll talk about it. How's that sound? And if I can bring up the script, I'll bring it up.
And then we have another backup utility to go through too.
Yeah. All right. Well, we'll see you on the other side.
So Nate, what's
all right? So that was fun.
We're gonna cover.
Great. No, we're save that for later.
A surprise backup. I don't like surprises in my disaster recovery, Nate. That's actually the whole point of having disaster recovery.
No, it's a utility included with RHEL called RHEL, which stands for Relax and Recover, which sounds lovely, doesn't it?
It does. All right. So disaster recovery. One is like having backups of data, right?
Yeah.
So we can use tar, RHEL, the utility du jour at your organization that, of course, should be your preference because they already have a method of managing that and doing disaster recovery operations with it. But what else do you have to think about when you're doing disaster planning, Nate?
So there's a rule of thumb which I was told years ago, which I've tried to live by kind of ever since, and that's the 3-2-1 rule. And when I mentioned this during show planning, Scott didn't know it either. So I do wonder how broadly this is known. But I know there are other people that follow this. It's not just me. But it's meant to make it easy to remember. You need 3 copies of your data. Now that could include the production data set, right? So you've got the production data is 1 copy. Your backup, maybe it's like an on-server backup or a local backup, could be a 2nd copy. And then a 3rd would probably be something that's at least off-server, right? So the data, a backup of the data, and a 2nd copy of the backup of the data, right? 2 says those pieces of data, those backups, should be spread out across at least 2 physical locations, right? And that doesn't just mean another server in the same rack. That means maybe another server in your 2nd data center. Maybe it's just in a 2nd rack, right? But the number 1 in the 3-2-1 rule is that one of those copies is offsite, right? So maybe you've got the production data, a 2nd copy that's on your local backup server, right? That's in the same data center, and a 3rd copy that's, I don't know, shuffled off to a cloud provider or put onto physical tapes or other medium and sent off to a storage facility, right? You need something that if your entire facility were to be hit by a meteor or burned to the ground, you have that data somewhere other than where the server existed, right? Because in a true disaster, like a flood, if your backup servers and your servers have been flooded, you need a 2nd copy of that data somewhere else, a 3rd copy, I should say.
Yeah. And then like where you choose to put it is another question. I worked for a company that had 3 data centers and they would replicate data between the data centers. That's good, right? We got multiple copies. They're in different physical locations.
Yep.
Except they were all in the same town.
Yeah. Right.
So like flood, fire, internet outage, because
power outage, internet outage. Yeah.
Providers are there, right?
Yeah.
That was like, great. We have 3 copies and we had 3 data centers. And that was all cool. But then they were in the same place.
They're all in the same place. So yeah.
I worked in another company where they were standing up a new data center, and watching them do this disaster recovery planning for where they should locate this new data center was like impressive.
Yeah.
So they chose to put their new data center in Colorado Springs, Colorado, because like you don't have to worry about floods in Colorado Springs, Colorado. You don't have to worry about earthquakes in Colorado Springs, Colorado. You don't have to worry about hurricanes in Colorado Springs, Colorado. And then there's also things like heating and cooling costs and other stuff that kind of goes into that. But, you know, the same company also had a data center in Florida. That was not the best choice for disaster recovery because that's more likely going to be one that's going to be impacted by severe weather.
That's the one you'll be recovering frequently.
And so like, I know how that data center in Florida was a historical data center. They had been put there for supporting operations in that part of the country. So I understand why it was put there. But when you're talking about things like, well, if a really bad hurricane comes through, what do we do? Right? You don't want to have your 2nd data center also in Florida. That probably
yeah, exactly. We when I worked at the college, we had 2 data centers, but they were only across campus from each other. Like literally, you could see one data center from the other. Now we were on a hill, and it was unlikely to flood and things like that. But you know, if there was a significant event like a fire that took out campus, or like we always use the example, what if there's a meteor? But we did, and we even had we had 2 internet feeds from 2 different providers. But there was one pole that they both touched. Luckily, no one ever hit that pole, but we did have a campus-wide power outage once, and it took out both data centers. And that really made us think about, well, we should really have something that's offsite, even if it's a minimal amount, just so like the college's website were to stay up, that kind of thing. Because obviously, if all the students are out of power too, we don't have to worry too much about classes going on, but we do want to make sure that people don't think Lafayette College has been flooded and or they've gone out of business. Right?
Yeah. So when you're doing that planning, not only is the 3-2-1 rule an excellent way to describe it, and Nate's right, I had never heard it described that way, but once he said what it was, I was like, oh yeah, I mean, yeah, sure.
Yeah, that's like the rules we follow, but no one's right. To hear it stated that way, it just makes sense.
Right. And then things like where are you really going to put it, right? I've heard people, especially for smaller companies, they'll have, they'll do a backup at their office, and then they'll bring a USB key or something home with them, right? So that they get that second location. And while
Yeah.
not ideal, it's certainly better than just leaving it all at the office, right? So
Oh
don't
yeah.
don't feel like if you're a small company that you need to have extra data centers and other geographies and
Yep.
whatever.
And
Um,
the other thing, the 3-2-1 rule can easily apply to your laptop as well as it does a whole data center, right? It's the same concept. If you have important data on your laptop, same deal. Make sure you've got extra copies of it. Make sure you've got a copy off site. Maybe it's just family pictures, right? That you want to make sure survives a disaster, right? And you want to store those somewhere else. Now that stuff gets a lot easier with cloud services that auto backup and whatever, but just keep that in mind, right? Maybe it's important financial data. Maybe it's your will. I don't know. Important
and then
stuff.
in addition to like how you actually choose to store your backups, the big question is what do you put in a backup?
Yeah, right. So my example from earlier today, in the critical path, why the heck would you include boot in your backup? Why would you include slash user bin in your backup? Right, which is what I did. But I did that mainly because I wanted to make sure it broke the machine when I restored it. These aren't things that you necessarily need to back up.
Well,
Maybe
but
you do if you're
like
like imaging a machine.
and
Sorry, go
like
ahead.
a number of episodes ago, we did a troubleshooting episode where we were borking the ability of the
Yeah,
system to boot in a variety of ways. And right, one of the things you did, Nate, was like delete the boot directory and all the
yeah,
contents in it. Well, if you
yep.
had a backup that had all that stuff, that would be pretty trivial to restore.
Right, but it was also relatively trivial to simply reinstall that from the source packages, right? So all of those things are included in the RHEL distribution packages. So yes, I had to do some fiddling after I restored them, like to rebuild the grub config and to reinstall the bootloader. But it's all pretty standard procedure stuff. There's no irreplaceable data in boot, or there shouldn't be.
Right. And that also leads us to like how do you actually restore, right? So some places they make full and complete system backups and their idea is they'll get replacement hardware and they'll just lay that content back down on the machine and have the same exact machine that they left. I've always used the idea that I will rebuild my initial system by reinstalling it. And then I have to put in the things that make it unique. So when I'm performing my backups, I'm able to back up less data because I'm only
Right,
backing up the unique bits. And I'm relying on things like being able to use a Kickstart or being able to have a cloud image or a virtual image that I can just replicate quickly to get all of the
right.
binaries and other stuff in place. And then I overwrite the pieces that I need to overwrite to make the piece the
Now,
system back to its initial state.
if you don't have infrastructure that makes it easy for you to quickly install or quickly duplicate systems, then it might make sense to keep full images of your important servers, right? So, yeah, you could easily, if you don't have like a Kickstart environment or you don't have like a quick cloud deployment methodology, that kind of thing.
So Nate, should we jump into the next demo?
Yeah, so I broke that machine earlier. Let's go back and fix it. What do you think? All right, here we go. So I've got my down system here, right? Now this is exactly where we left it when um we did that tar incident at the beginning. Now, the tool I wanted to show you, and we've already mentioned this, is RHEL, relax and recover, right? What RHEL does is it actually makes a bootable ISO that you can restore a machine from, and it restores essentially like a machine image. Now, you have to make sure there's certain things that are the same. Like RHEL will actually restore the partition table of the machine and restore the data to those partitions. So if you boot it up on a new machine that doesn't have the same disk geometry, there are ways to account for it, but RHEL isn't going to be able to just automatically restore because it doesn't know how you want those disks laid out. So I've already got this machine set up so that the boot order, I don't know if you can see my cursor on the screen, but the boot order here is configured so that it will boot from an ISO file if I attach one. At the moment, I don't have one attached, but we're going to attach one. And I've already got that created so that you guys don't have to watch me make one and copy it around. So it's in var libvirt ISOs, and it's called RHEL ITT 137-0 because that's the name of the server that I ran RHEL on. And I'll show you how RHEL gets configured once we get the machine back up and running. All right, so we've attached the disk. We're just going to reboot the machine. So I think I'll have to do a force restart on this thing because it's in a weird state. We're going to expand the console so you can see better. All right, so now it gives us this handy boot menu. And you can see it by default, it says boot the first local disk, because that's probably what you're going to do if you've accidentally left this DVD or this ISO attached to a machine. But in our case, we already know the machine's not going to boot. So we're going to do an automatic recover. Now, this first option, recover, will bring you to a recovery prompt. So if you know that there's going to be issues with how you recover and you don't want to just automatically overwrite the machine, you'd want to do that. And then there's commands you can do that'll be a little more advanced. But we're just going to do an automatic recover because we know this whole machine is just completely borked. So we hit enter, and it's going to bring us to a confirmation prompt once it finishes booting. Now, what this is doing is it's bringing us into a very bare bones booted environment that has networking, because it has to be able to get my backup from the place that I stored the backup at. That's not actually included on the ISO file. So we're going to show you that in a second. Okay, so now it's asking me, are you sure you want to do this? Do you want to proceed with the recover? We're going to tell it yes. Hit enter. And it's just going to go ahead and do it. Now, this does a pretty verbose output here. So we'll kind of walk through what's going on. You see right there, it's creating file systems. You can also see that it checked, let's see, somewhere up here that the disk was the same, so that it looked, so it knew the disk geometry was the same size. And now it's actually restoring that backup tar gzip, which, believe it or not, this does use tar gzip. So that's kind of my example from earlier about times when that preserving absolute paths is important, because that's exactly what it's doing here. Kind of ironic that tar gzip broke the machine in the first place, and now tar gzip is fixing it. All right, it actually goes through and builds a new grub config, because obviously you wouldn't necessarily have that. It's making sure that things like UUIDs and whatnot are correct, and then rebuilding the grub config. Now, the UUID should be the same because this is an identical system. But if you're restoring to a similar but not identical system, those may be different. So it has to account for that. All right, and then it asks us, what do you want to do next? We can go into a shell, or we can view the log file, or we can just reboot. Now, I trust that it did its thing because I was watching the log output. So we're going to hit number 3 and let it reboot. And I should have disconnected that ISO file. All right, so this is exactly why it boots from the local disk instead of right into the recovery mode. Otherwise, it would go into this loop of recovering over and over again. So we're going to say boot from the first local disk, and then it's going to bring us to the grub menu, which is already better than we were before. And while it's doing this, well, I'm not going to disconnect it. I was going to hop over and disconnect that that ISO file, but I want you to see what's going on here. It boots the system, and then it kind of hangs here, and then it reboots again. And the best I can figure what it's doing here is an SE Linux auto relabel, because that feels exactly like what it's doing, right?
Even that is exactly what it is doing.
Yeah, that's got to be what it's doing. So we're going to let it boot now, and it should come back up with my system. Now, I made this ISO literally half an hour before we went live, so I know it's got the right data in there. But I'm going to show you in sort of the extension of this demo here how it gets configured and where it gets its configs and whatnot from. So RHEL it's just a package called RHEL, R-E-A-R. You can just DNF install RHEL, and what you get is the tooling that makes RHEL work. And then inside of Etsy RHEL, it builds some basics. I guess there's a certificate involved that gets thrown in there. But the local.conf, and there's also, I forget if it's the os.conf or if there was a third file. One of them is meant for like general defaults that you're deploying to all your machines. And then if you have specific things that this machine is supposed to back up, there's a second config file. And I think it mentions it inside of the RHEL local.conf. Yeah, it mentions it here. Local.conf. I thought it told me which one it went to. Oh well. Intended for the user's manual configuration, relax and recovery. Anyway, there's separate config files for site configs and for specific configs for this machine. Now, what I've thrown in here is I told it what I want it to output to, what kind of backup I want it to create. So this is telling it when you do your, I don't know how readable that is on stream, but this is telling it that when you do your backup, make an ISO file so that I have a specific ISO file that I can boot to restore this machine from, right? So when it makes the backup, it'll make the archive file and this bootable ISO that'll tell this machine how to restore that archive file. Now, output URL. You might think that that's a little misleading. Like you might think, well, why would I point it to a URL? But notice what I have in here. It points to an NFS share, right? And there's also this backup equals netfs. That's the backup sort of storage backend. And there's about a dozen different storage backends that RHEL supports. One of those is Bacula, which is another tool that's included with RHEL. You can install that right from the repositories. But basically, Bacula is a lot more complicated to get set up than just NFS, which is why I used NFS. It's kind of a larger, more complicated, more sophisticated backup system. But there's also things like you can point this to Tivoli Storage Manager, which is something that I had used in a previous job, which is a pretty nice backup system. There's a bunch of, Scott had mentioned earlier, there's a bunch of different vendors that we work with that are partners of Red Hat that offer different backup solutions. So you can also look there to see if there's a different storage backend that also works with RHEL if you want to use RHEL. All right. Let's see. Output URL, backup URL. This basically tells it these are two different directives for where things are supposed to be stored to. We can have some exclusions. I just went with the defaults that are in here. Right, there's some built-in backup exclusions, and then there's also it added /media, var temp, and var crash because those are things that are going to either be useless or big, right? Big that maybe you don't want, like var crash. That's going to have crash dumps and whatnot. Sometimes those get enormous, and maybe you don't want to include those in your backups. And then you can tell it, you can also add in options that'll make it do incrementals instead of full backups. I decided to do full backups because I didn't want to add some complexity with incrementals to this particular demo, but note that does exist, and that's a thing you can do. And of course, do you want to keep the old copy of the backup is that last thing. I left it at the default, which I think tells it not to keep the old copy. You can turn that on if you want 2 revisions. And so if you're not using incrementals, you have a second copy, like the last full backup is still there.
So Nate, one note on incrementals, since you mentioned it.
Mm-hmm.
Incremental backups are where you run the same backup utility, but it looks at things like the last modified timestamp on files to decide whether it needs to back up a file or not. And so the ultimate result is you get less stuff in your backup because there hasn't been changes. Right. So you save. The flip side is you increase your restore complexity. So in order to restore, you now start with your full backup, and then you have to lay on, in order, all of the incrementals after that to rebuild your system back to its current state. So, with storage the way it is, full backups are pretty sweet. Rather than relying on incrementals. But
if you're backing up a whole data center full of systems, sometimes it isn't the space you're worried about. It's how long does that take? Can it finish the backup in a I don't know 8-hour period overnight? And if it can't, then incrementals might be a way to work around that problem. So just things you need to weigh when you're planning how to get these things done. Okay, then the other thing I wanted to show you was how do we actually create a backup with RHEL? You already saw how to restore a backup, but it's actually really simple. And this is something you could throw into a cron job or something. I'm going to do it with some very verbose output so you can see what's going on. If you're doing this in cron, I wouldn't bother with the verbose output because it does store a log file that you can go look at later. So if we just do RHEL and then -D and -V, turn on debug and verbose. Verbose is a hard word to say, Scott. Why do we have to use it so much in IT? Verbose output and debug output. That's so that it outputs more to the screen so you can see what's going on. And then we just do mk backup. Now there's a subcommand of mk backup that's mk backup only, I think it was, that just does just a file backup. It doesn't do the ISO and everything, but I don't want to do that. I want to do the ISO because I want to be able to recover as quickly and easily as I just showed you in that demo. So you can see here exactly what it's doing. Sorry, go ahead.
Quick note on ISOs. So if you actually want to make your backup on a piece of physical media, that's also going to determine the size of your backup, right? Because you can only put 8 gig on a dual layer DVD piece of media. And if your ISO formatted backup is 12 gig, you can electronically move it around. You can attach it to stuff like Nate did in his demo. That's all fine because it's the right format to be understood as an ISO. But you won't be able to take something more than 8 gig and actually press it or burn it onto on a piece of physical media.
So the cool thing about RHEL, and I don't know if there's a way to configure it so it packs the entire backup onto that ISO, it actually puts a skeleton on the ISO. The ISO is actually pretty small, but then it assumes that it can reach the network and it can reach the place where you've stored the full backup, and it can go get it and pull it down. So it doesn't all have to fit on the ISO, which is handy. So, well, actually, while it's doing this, no, maybe not. The last thing I wanted to show you was where I can actually get to the NFS share that is stored at, and you can see what that looks like. But I don't want to move away from this window, and then you miss all the exciting output.
Well, while it's building, Billy actually mentioned in chat about infrastructure as code, and I've heard several different variations of this. Some people call it GitOps. There's a bunch of options. And maybe we'll talk about that after, because now you just finished.
Yeah. So this gives me a suggestion that I'll probably want to remove the var temp rear dot yada yada yada. That's the temp directory that it used to make this backup, and that's mainly just to save space, right? On the production machine. So if I'm running these things nightly, that var temp directory is going to get more and more full every time I run one of these backups, right? So you may want to, if you're scripting this, you may want to have it check for temp files called rear.something and clean those up after they run. So just keep that in mind. Var temp is one of those, I don't think it automatically empties. Temp automatically empties, but var temp does not. So you will definitely get cruft in there.
It does automatically empty.
It does.
But instead of removing things that haven't been accessed in 10 days, var temp removes things that haven't been accessed in 30 days.
So yes, you'd have 30 days of backup sitting in there, which would probably get large. Okay, so it finished the backup, and there's not much else to show you on this particular machine. What I can do is drop down to the terminal here, which is this is on my hypervisor. I happen to have the NFS share. Oh, only if I could type my password. Oh, I wanted sudo. Hit the wrong button, then it reloaded. Sudo su dash. I'm not even sure what the root password of this machine is. I never use it. Anyway. So in here, and this is just a mount on my local NAS. You can see this .old file here. That's the last copy of the backup that it created when I made the backup, right? So I think it only keeps one extra copy. Maybe there's a way to configure that so it keeps more. I don't know. But this ITT137-0, it's the name of the server. That's the host name of the machine that I backed up. And if I look in here, you're going to see there's a README file, which kind of gives me some basics about how I would use the restoration. Really, all it tells me is, dummy, don't copy the ISO onto a DVD, burn it to a DVD, or boot from it, which is funny that's what they've included in the README. That's all they've included in the README. But anyway, there's that backup file. Right, and this is the file that it pulls down. Here, let's do an LH on it so you can see how big it is. You can see it's 1.2 gigabytes. So that's all the amount of data that it was able to get out of, or all the data that it thought was important to get out of that machine. And that is the whole machine, right? Because you saw it. I actually, my initial demo was going to be use DD to write zeros to dev VDA. And then I restored from this. So I tested that and it worked. Right? It doesn't need any data. It doesn't depend on any data being present before you get started. So anyway, let's see. Was there anything else I wanted to show here? There's the ISO file. Right? And you can see the ISO file is only like 400 meg. I forgot the LH again. Yeah, 446 meg, and that's that small, compact operating system that you're able to boot up, and that'll fit on a CD-ROM. Who remembers those? 650 megabytes. So you don't need a lot of infrastructure to try to boot that thing up, but it does assume that you will be able to connect that machine to the network and it'll be able to reach wherever you stored those backups to, right? But all the configuration it needs to know about is baked into this ISO file. So if you've got authentication mechanisms or whatever built into RHEL, they should end up in that ISO file so that you don't have to worry about supplying that when you're trying to restore.
Yeah,
And I think
and
that's it.
Hank mentioned in the chat that he'd never heard of RHEL before. RHEL started shipping with Red Hat Enterprise Linux 8. So you'll find it in RHEL 8, 9, and it is currently in 10 beta. So I expect to see it in RHEL 10 later on in the year when we release that.
Yep. Yep. So it's good stuff. I actually first heard about it not until I was at TAM. One of my customers were like, we started using RHEL. And I'm like, what's RHEL? I had to go learn about it.
So back to infrastructure as code or GitOps or whatever you want to call it. So that's a method that's actually really common in places like cloud deployments because you're constantly deploying from an image, and then you have to work that image into something that's usable for your application or however it's going to be utilized within your infrastructure. And I actually used to do this a lot like 20 years ago. So 20 years ago, I was a instructor for Red Hat training. And I would show up to teach a class every week, which meant that I had to install the boxes for class every week. And so every week I had a brand new system that was my system for the week.
Yep.
And so that's one where I learned how to be very comfortable with the defaults of the operating system. Because like if you're rebuilding something every week, you don't want to get super fancy and spend an hour customizing it, because that's an hour that you're wasting every week, right?
Right.
But then you also start thinking about, well, what are the things that are really important to me? And so something like a tar archive, or I actually ended up checking a bunch of stuff into Git and just would do a Git pull down to my machine to set up the things I needed or track the files I wanted to track so that I could rebuild stuff when things went awry. And that got me started into like never storing things locally. Always store stuff I care about over there. That way, if I drop my machine in the river, well, I'll get a replacement machine and pull down all my files to it, and I'm good to go.
Store the important stuff. Yeah. So this comes back to that. How quickly can you redeploy the stuff that's replaceable, right? The closer you get to automated system deployments and automated application deployments, the less data you have to worry about. Is that in the backup? Really, eventually you can get to a point where the only thing that matters is the data that needs to be persistent, that dynamic data that the application depends on. So just imagine you're deploying a database server. The database itself is probably the most important thing that you need to save, maybe some config options and whatnot. But if you get all of that baked into your deployment mechanisms, right? If you've got automated deployments that get the database laid down, get all the config in place that needs to be there, and the only thing you need to worry about is the data itself being in the backup, that makes recovery a whole lot easier. You just click a button, new database server pops out, you get the database pulled back in, and you're back up and running.
Yeah. And, the other thing we haven't talked about yet is like actually testing things, right? So you always want to test that your backup methods are sound. One, that you're actually capturing the data you think you're capturing in your backups, and that you're reliably doing it, right? So don't just be like, oh, that one time I checked it and it was fine. So now 4 years later, I've been running backups every week. I'm sure it's fine. No.
I've shared a story. I forget if it was on this show or not, but a number of times about the time that I accidentally cooked the Rev Manager for our virtualization infrastructure when I worked in higher ed. But I thought I had backups, and it turned out for months my backups had stopped working because of something that changed in an upgrade. Right. So yes, I am living proof. Validate your backups. Make sure they work. Make sure they contain what you think they do, and do spot checks from time to time. A lot of places, especially that have more mature disaster recovery plans, do disaster recovery drills from time to time, where they're not just talking about it; they're actually doing it. They go to their remote site. Maybe if that's a virtual site, they do it virtually, and they try to restore some things, some of their core services, and see if they work like they're supposed to.
Yeah. And I see in chat, Shantanu said, Pixie installing beats image complexity, in my opinion. I agree. That company I was telling you about that had three different data centers in the same city.
Mm-hmm.
To do a restore of a machine would take like 10 hours
Mm-hmm.
using the backup software that they had. And doing like full and complete system backups. It would take 10 hours to restore. Conversely, I could stand up a new replacement box with a Pixie Boot Kickstart in about 10 minutes. So if I can Pixie Boot
Right.
Kickstart 10 minutes and then not have to restore gigs and gigs and gigs of data, but instead only like 1 gig or 300 meg, my recovery time goes from 10 hours to an hour and 15 minutes. Which would you prefer? I know I would prefer the less time.
Yes. Yes. Now, sometimes there's a little more legwork involved in the less time, but you get up so much faster, right? Like by legwork, I mean I had to think about deploying a machine, making sure it had the right specs and whatnot for the thing I'm going to restore to it, and then restore the backup, right? Whereas if I'm just blindly restoring the backup, I'm blindly restoring the backup, right? If I'm doing a rear backup, like my example here, it's just like, oh, make a new VM, attach the ISO, click the button, and wait. What if that took 10 hours?
Yeah. Well,
Right?
that also assumes things like the hardware that you're attaching is the same hardware that you lost,
Right. Right.
right? Whereas if
Exactly.
you do a Kickstart install, it installs on the new hardware, whatever that is, and you're only pulling back the configs and whatever else that's really hardware independent. You can do, actually, Linux is really great about restoring things on changed hardware because the kernel will be like, whoa, this is weird, but okay, I have the driver for that. Um, and some things like, uh, different MAC addresses for NICs and stuff like that will like mess stuff up.
Yeah.
So you do have to be somewhat aware. And that's the other reason why I like a install replace
Right.
rather
The
than
OS is clean then. Yeah.
right. And I can like, oh, that 20-year-old hardware that I lost in the flood. Well, now I get brand new thanks to the insurance company
Right.
hardware, which is a little bit different, and I need to treat it a little bit differently.
And then sometimes that turns into, that machine that was lost in the flood that was 10 years old had an OS that was two versions older on it. And now I need to figure out, am I putting something new on? Am I trying to replicate the old stuff? Am I going to regret that later? Right. So there's a lot that goes into this.
Well, but that's part of your DR planning, right? And that's the
Yeah.
other, I think, piece that we didn't talk about. We talked a lot about the tools and like how you use the
Yeah. Yeah.
tool, ways of using the tools, but you also have to have an overall plan, right? So one of the most organized places I worked for disaster recovery, they had tiers. And tier one was like critical
Yeah.
applications that need to be restored first. And then tier two was like supporting applications that would be really nice to have, but don't make their way to tier one. Tier three was like, yeah, I mean, I guess. And tier four was like, we could live without that, but I guess if we were putting everything back, we'd put those back too.
We'll replace that
Um,
someday. Yeah.
right. And so, they would do a DR plan and they'd periodically come to us and be like, hey, go through your entire system inventory and rate which tier all of these systems are in. And so we'd go through and like update those parameters. The tiers also typically had SLAs, so like tier one stuff had to be back within 1 day.
Hmm.
So if there was a disaster, we would be expected to restore all of our tier one things within 1 business day, or 1 24-hour period.
But when you're rating those tiers, right? You got to think about not just what's most important to the business, what's most important to the recovery effort, right? So if satellite, great example. We talked about this when we were planning the episode. Satellite might seem like it's tier two because, you know, having the system up is important. Being able to update the system is important too, but maybe day two important, not day one important. However, if your recovery mechanisms depend on Kickstart and that's hosted by satellite, that's not just tier one, that's tier zero. That has to be there before you can start tier one, right? So just keep that in mind when you're planning this stuff.
Yeah. And so like, and frequently reassess your population and decide whether you're the right settings or things have changed.
Right.
And then you come up with like, how am I actually going to restore this? What are the processes through which I actually rebuild and remake this thing in the timeline that I was assigned, right? That may make other choices like how you perform your backups, how you perform your restores. The timeline on which it has to be done may help make those choices. So when you make your plan, you know, think about what you need to be back operational first, second, third, how long you expect it to take, or how long you're told it will take by someone else, another business owner or something.
Right.
And then that can help inform some of your decisions and practices and what you're backing up and other stuff there too.
And I had at an information security conference years ago, I had talked to a company that they had made a card game for this is for information security breach incident response, but it's a similar concept, right? They made a game called Backdoors and Breaches. And if you've never heard of these people, then I'm not really going to give them a plug on the show. But the idea was the card game gives you an incident to respond to, and then it throws curveballs at you. Like there's cards in here. Like here, this one is legal has taken away your most skilled handler to ask them for a status update. So like imagine your senior sysadmin was pulled into a meeting for 20 minutes and now they can't help you. Or let's see, there's another fun one here. Oh, Bobby the intern kills the system that you're reviewing. Right? So I'd love it if there was a card game or something like this for normal IT disaster response too. If anyone knows about one, I'd love to hear it.
Cool.
All right, I think that's all the topics we had. Do we have anything else?
No, I think that was it. But don't forget to mash that like and subscribe. We'll do this again next week. I don't know what our topic is for next week, but we'll have one.
Maybe it won't involve me cooking my lab system before we start the show.
But you loved it. That was your idea.
It was fun. It was fun. And there was a number of comments about my spectacular acting, Scott.
I mean, it's impressive that I didn't think there was actually what happened. Because there are times where, of course, we cook things and it was not on purpose.
Yeah, but I don't do that, Scott. That's you. You do that.
Okay,
it's only
fair.
you.
Point. All right. Well, join us next week for another Into the Terminal, to be determined. But we will see you next time.
Everybody have a great one.